So let's start with the last tutorial on machine learning. Now here we are going to discuss reinforcement learning. Reinforcement learning is an area of machine learning concerned with how software agents ought to take actions in an environment in order to maximize the notion of cumulative reward. So what is reinforcement learning? Reinforcement learning is a method of machine learning wherein the software agent learns to perform certain actions in an environment which lead to maximum reward. So objective is to maximize your reward. It does so by exploration and exploitation of knowledge. It learns from repeated trials of maximizing the reward. Reinforcement learning versus the rest. Methods of machine learning other than reinforcement learning are as shown below. You can see that machine learning, you have supervised, unsupervised and reinforcement learning. So reinforcement learning, agent learns to interact with the environment to achieve a reward. One can conclude that while supervised learning predicts continuous ranged values or discrete labels, classes based on the training it receives from examples with the provided labels or values, unsupervised learning tries to club together samples based on their similarity and determine discrete clusters. Reinforcement learning, on the other hand, which is the subset of the unsupervised learning, performs learning very differently. It takes up the method of cause and effect. Now, intuition to reinforcement learning. Let us try to understand the previously stated formal definition by means of an example. Imagine you are supposed to cross an unknown field in the middle of the pitch black night without a torch. There can be pits and stones in the field. The position of those are unfamiliar to you. There is a simple rule. If you fall into a hole or hit a rock, you must start again from your initial point. You can start walking forward blindly, only counting the number of steps you can take. Then after X steps, you fall into a pit. Your reward was X points. Since you walked that many steps, you start again from your initial position, but after X steps, you take a detour, either left, right, and again move forward. You hit a stone after Y steps, so this time your reward was Y, which is greater than X. So you decide to take this path again, but with more caution. When you start again, you make a detour after X steps, another after Y steps, and manage to fall into another pit after Z steps. This time the reward was Z points, which was greater than Y, and you decide that this is a good plan, a good path to take again. You restart again after they make the detours after X, Y and Z steps to reach the other side of the field. Thus you have learned to cross the field without the need of the light. Now some terminology that we must know is like agent, a hypothetical entity which performs actions in an environment to gain some reward. Action is depicted as A, all the possible moves that the agent can take. Environment is depicted as E, a scenario the agent has to face. And state S, which is depicted as S, current situation returned by the environment. Now reward R, which is shown as R, an immediate return sent back from the environment to evaluate the last action by the agent. Policy pi, the strategy that the agent employs to determine next action based on the current state. Value V, the expected long-term return with discount as opposed to the short-term reward R. V pi S is defined as the expected long-term return of the current state as S under policy pi. So Q value or action value Q value is similar to value except that it takes an extra parameter. The current action Q pi with the S as the state and A as the action refers to the long-term return to the current state S, taking action A under policy pi. So policy pi is nothing but your plan. What action plan? How reinforcement learning works. There are majorly three approaches to implement a reinforcement learning algorithm, and these are value-based. In a value-based reinforcement learning method, you try to maximize the value function Vs as defined in the terminology previously. V pi s is the expected long-term return of the current state S under policy pi, and thus Vs is this value of reward which agent expects to gain in the future upon starting at that state S. So this is the kind of equation that can be created. So policy-based reinforcement learning method, you try to come up with a policy such that the action performed at each state is optimal to gain maximum reward in the future. Here, no value action is involved. We know that the policy pi determines the next action A at any state S. There are two types of policy-based RL methods. Deterministic, at any state S, the same action A is produced by the policy pi. Stochastic, each action has a certain probability given by the equation below. So this is the equation which can be used for that purpose. Model based, in the type of reinforcement learning, you create a virtual model for each environment, and the agent learns to perform in that specific environment. Since the model differs for each environment, there is no singular solution or algorithm for this type. Now, Markov decision process. The Markov has created a process which can be used. Now, Markov decision process is a discrete time stochastic control process. It provides a mathematical framework for modeling decision making in situations where outcomes are partly random and partly under the control of the decision maker. The Markov decision process comes under reinforcement learning. It is a type of machine learning. It allows machines and software agents to automatically determine the ideal behavior within a specific context. In order to maximize its performance, a simple reward feedback is required for the agent to learn its behavior. This is known as the reinforcement signal. Now, there are many different algorithms that tackle this issue. As a matter of fact, reinforcement learning is defined by a specific type of problem, and all its solutions are classed as a reinforcement learning algorithm. In the problem, an agent is supposed to decide the best action to select based on its current state. When this step is repeated, the problem is known as Markov decision process. So that it keeps on repeating unless you get the most suitable model or most suitable outcome. A Markov decision process model contains a set of possible word states S, a set of models, a set of possible actions A, a real valued reward function R with the state S and action a policy, a solution of Markov decision process. What is a state? A state is the set of tokens that represent every state that the agent can be in. What is the model? A model, sometimes called transition model, gives an action effect in a state. In a particular, when you are in transition, you start with a state like S, then A is the action, and then you reach S dash. Defines a transition T, where being in state S and taking an action A takes us to the state S dash. For stochastic actions, noisy, non-deterministic, we also define a probability P, S dash divided by S, comma A is the action, which represents the probability of reaching a state S dash if action A is taken in state S. Note, Markov property states that the effects of an action taken in a state depend only on that state and not on the prior history. Now, what is action? In action is A is set of all the possible actions. A defines the set of actions that can be taken being in state S. And what is a reward? A reward is a real valued reward function. R indicates the reward for simply being in state S. R within bracket S, comma A, that is state and action indicates the reward for being in a state S and taking an action A. So our reward is a function of capital S, A action, and S dash, that is the next state, indicates that the reward for being in a state S, taking an action A, and ending up in a state S dash. So what is a policy? A policy is a solution to the Markov decision process. A policy is a mapping from S to A. It indicates the action A to be taken while in a state S. Let's take the example of a grid world. Now the agent lives in a grid. The above example is 3x4 grid. The grid has a start state, grid number 1, 1. The purpose of the agent is to wander around the grid to finally reach the blue diamond, grid number 4, 3. Under all circumstances, the agent should avoid the fire grid, orange color grid number 4, 2. Also the grid number 2, 2 is a blocked grid. It acts like a wall, hence the agent cannot enter it. You can go back and see that, yes, this is the fire, and these are the gates, and this is the way you can proceed further. Now the agent can take any one of these actions, up, down, left, right. Walls block the agent path, and if there is a wall in the direction of the agent would have taken, the agent stays in the same place. So for example, if the agent says left in the start grid, he would stay put in the start grid. First aim to find the shortest sequence getting from star to the diamond. Two such sequences can be found, that is right, right, up, up, then right again. Second is up, up, right, right, right. So whatever suits, you can go for that. Let us take the second one, that is up, up, right, 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 for the subsequent discussion. The move is now noisy. 80% of the time the intended action works correctly. 20% of the time the action agent takes causes it to move at the right angles. For example, if the agent says up, the probability of going up is 0.8, whereas the probability of going left is 0.1. So the probability of going right is 0.1, since left and right is right angles to up. So the agent receives rewards each time, and the steps are small reward. Each step can be negative when can also be termed as punishment. In the above example, entering the fire can have a reward of -1. Big rewards come at the end, good or bad. The goal is to maximize the sum of the rewards. So that is how this whole process goes. So this completes the machine learning topic. Thank you.